All right, so this last lesson in the unit focuses on quadratic inequalities. Now, the last several lessons have been focusing on quadratic equations, solving an equation, finding the value of x or values of x. Solving a quadratic inequality is when you have, instead of an equal sign, essentially you have a less than or greater than sign, or less than or equal to, or greater than or equal to. They're called inequalities. And so it's quite definitely going to build upon all the lessons we had from chapter 4. So what I have here is a quadratic function, and I've called it f of x. There you go. Okay, so I want to use this graph of y equals f of x to answer these. And if you look at these questions here, there's the first two are equations, the following three are inequalities. All right, so let's look at the equations first. Where does f of x equal 4? And again, f of x is this graph. So where is this graph equal 4? What does that mean? Well, x is the input, f of x is the output. It's the y value, y equals f of x. So f of x represents, the outputs of this function. Again, x represents what goes in, y represents, or f of x represents what goes out, the output. So why am I reminding you of this? Because if I'm trying to ask, from looking at a graph, where does f of x equal 4? That means from the graph, I'm trying to think, where is the output equal to 4? Where does y equal 4? Well, I can just see on my y-axis, there's 4 right there. And so at that point, and at this point right here, at these 2 points, my function equals 4. So where is that? Where in terms of x? Because if you look at the equation, I don't know what x is, I just know what f of x equals 4. And so at this point, x is 0 and negative 3. So f of x equals 4 when x equals 0 and negative 3. So notice I solved an equation using a graph. And if I actually gave you the equation of function f, which again we could figure out using previous lessons, I could solve this algebraically and I should get the same answers. Okay, so one more example before I look at inequalities. Where does f of x equal 0? Where does the output equal 0? Well, that's where my y-coordinate is 0. So right there and right there. Those are the 2 places where my output, my y values are 0. And where are those? At 1 and negative 4. So x equals 1 and negative 4. Those are the solutions. And again, the entire focus of the last chapter was solving quadratic equations. Okay, so now I have some inequalities. Where is f of x greater than 0? So that means where are the outputs, where are the y values more than 0 but not equal 0? Well, if I look at that, that's this entire region here. Everything here that I'm highlighting in green has an output, has a y value that is greater than 0. Whether it's a little bit more than 0 or it's significantly more than 0. So how do I describe that interval? Because this is not a point, this is that whole interval. And how do I describe it in terms of x? Because again, if I look at my inequality, it's the x that I don't know. It's the x that I'm trying to figure out. Well, this interval I highlighted in green is everything between negative 4 and 1, but not including negative 4 and 1. Because at negative 4 and 1, the equation equals 0. I want where it's greater than 0. So to express that whole interval between negative 4 and 1, I can say where x is between negative 4 and 1, like that. Or negative 4 is less than x, which is also less than 1. There's my answer. Notice how these two are not the same, but they're related to one another. Asking where f(x) equals 0 and asking where f(x) is greater than 0 are definitely related to one another. And just like we're going to see the same sort of thing here. Now I'm trying to find where f(x) is greater than or equal to 0. Really, this question here is these two right here combined. Because basically it's the exact same thing as before, but I want to include negative 4 and 1 because it can be greater than or equal to 0. So my interval is almost the same thing as before, except it's negative 4 is less than or equal to x, which is less than or equal to 1. Tiny little change. And then where is f(x) less than 0? Well, that's this whole region here, which goes on forever, and this whole region here, which goes on forever. This parabola never stops, so indefinitely it goes on, greater or more and more negative outputs, y values. And so where is f(x) less than 0? In 2 intervals. In terms of x, everything less than negative 4 and everything more than 1. So I need to express this as 2 separate intervals, because if you look at what I've highlighted, those highlighted regions in yellow do not connect, and they never will. So I need to write 2 separate intervals, where x is less than negative 4 and when x is greater than positive 1. Now that's it. Just like when you're solving an equation, it doesn't have to equal 0, so it's kind of nice if it does. And with an inequality, it doesn't have to be greater than or equal to 0. In this case, what about if it's greater than -6? So I've kind of drawn on this graph a lot. Let me clean this up. So that again means where the output is more than -6. So -6 is right here. And so if I look at that little part there, where is this graph more than -6? Well, everything above those two circles I just drew. Right, this whole region here. This whole interval here, everything is more than -6. And so in terms of x, because again, I'm solving an equation, or an inequality, I should say, the x is what I'm trying to figure out. So where is, in terms of x, where is this interval more than -6? Between, but not including, -5 and 2. So -5 is less than x, which is less than 2. All right, so while inequalities are not the same as equations, it's very, very similar. And quite often, not always, but usually our answers with an inequality are an interval. They're not a point or a set number. It's an interval of numbers, right? Not just 4 and 1 or -4 and 1, everything in between -4 and 1. All right, so that's it. What if I don't have a graph? Well, I want to look at the equation y equals x squared minus 3x minus 4, and I want to use it to solve these two equations right here. Where is x squared minus 3x minus 4 less than 0, or is it greater than or equal to 0? So if I just gave you these questions, the first thing I would recommend doing is this, which is let's visualize the basics of this graph. When I say the basics, all that really matters is where are its x-intercepts, and is it opening up or down? So if I want to find its x-intercepts, I can figure that out if I can factor this. And if I can factor this, I can visualize this graph really, really quickly. What multiplies a -4 and adds to -3 is -4 and +1. So those are my factors, which means I know this function has x-intercepts at -1 and +4. I know it goes to those points. I also know the function's opening up because it's just x squared. It's not -x squared. So I can visualize this now something like this. Now where's the vertex? I actually don't care. If I wanted to figure it out, I had to complete the square, put it in vertex form, but I do not care. There's my graph. Really quick graph of y equals x squared minus 3x minus 4. So I want to use this now in the same way as before to answer these two inequalities right here. So first, where is x squared minus 3x minus 4 less than 0? Well, that's this whole interval right here. And what is that? Between -1 and 4. And so on a number line, all I need to show are two things, the numbers -1 and 4. I'm trying to find where it's less than 0, not less than or equal to, so I don't want to include these numbers, so I want to put kind of round open circles around them. But I want to show everything in between as part of my solution, so we just kind of shade a number line in between. There we go. What I have there represents what you see highlighted in blue up above. And I can express that algebraically by saying -1 is less than x, which is less than 4. And so similarly, where is x squared minus 3x minus 4 greater than or equal to 0? Well, that's in these two intervals up here. I'm trying to find where it's greater than or equal to 0, so I want to include the numbers -1 and 4, because at those points, the output is exactly 0. So on a number line, it's going to be two separate intervals. And the only numbers I have to show on the number line are, again, -1 and 4. This time, though, I want to include them, so I put a circle around it and I fill it in. And I shade everything to the right of 4 and everything to the left of -1. That's what the solution looks like on a number line. How does it look algebraically? I can say, again, I have to write two intervals where x is less than or equal to -1, comma, x is greater than or equal to 4. And again, what you see here is equivalent to this, which is equivalent, which I got from my answer up there. And so keep in mind, again, if I just gave you these questions, this became significantly easier once I visualized that. And to visualize that, I just need to think back to aspects of chapter 3, I guess. And again, I didn't care where the vertex was. All I cared is where are the x-intercepts, is it opening up or down? That's all that matters. And all that was quite quick. But it does require me to connect several ideas from this unit together. Hence, it's a good way to end the unit. All right, so Solve this. Where is negative x squared plus x plus 12 less than 0? Notice I already have a sort of simple xy coordinate plane set up. Well, again, I want to visualize this graph. One thing I can tell right away is if I visualize, or I should say I want to visualize the left-hand side, where I want to visualize that as a quadratic function. The one thing I can tell right away is it's opening down. But where are the x-intercepts? Well, if I want to find the x-intercepts again, I want to factor this. And the first thing I would do to factor it is factor out that negative. Because, well, first of all, it's pretty easy to do. And if you want to think about it as a negative or -1, you're factoring out. And now to factor this part here, I don't have to worry about there being a negative coefficient in front of the x squared. I just have to think, what are two numbers that multiply to -12 and add to -1? And those two numbers are -4 and +3. Plus the negative in the front. So now, what I see highlighted there in yellow at the end, that gives me all the information I need to perfectly visualize my answer in the end. But first, let's visualize my graph. X-intercepts at -3 and +4. And I know it's opening down. And that's all I need for this question. Again, where is that vertex? I do not care. I'm not going to waste my time for it. So this is my work. My work is set up. And now I can answer, where is this less than 0? Where are my outputs less than 0? Well, they equal 0 at -3 and 4. They're less than 0, anything to the left of -3, anything to the right of 4. So how can I express that? Algebraically, I can say basically what I just did. X is less than -3, comma, x is greater than 4. Here's my answer algebraically. On a number line, all I need to show, I can show other numbers if I want, but I wouldn't. Just show -3 and 4. Everything less than -3 but not including it, so I have an open circle. Everything greater than 4 but not including it, so again an open circle. There we go. So notice, it doesn't actually take me very long, but it does force me to connect several aspects of this unit together. Don't be surprised if you find these questions challenging. Really, if the only way you can proficiently get to correct answers for these questions is if you have a pretty proficient understanding of several key aspects from this unit. But that's, like I said, why it's a good way to kind of end the unit with this. All right, I want to solve where 2x squared minus 7x is greater than or equal to 12. Now again, I have nothing against the number 12, but the number 0 is far more convenient. So the first thing I would definitely do is subtract 12 from both sides and think about where 2x squared minus 7x minus 12 is greater than or equal to 0. And this is what I now want to focus on. I want to visualize the basics of this. I can tell it's opening up, but I don't know where the x-intercepts are. So let's see if we can factor it. Well, the first thing I would see if I can do is I can take out that factor of 2 from the front, but I can't because 2 is not a common factor. Okay, so next, let's multiply 2 and -12 together and get -24. And think if there are two numbers that multiply to -24, but add to -7. Go through the choices, 8 and 3, 6 and 4, 2 and 12, 24 and 1, and nope, this cannot be factored. So what does that mean? That doesn't mean there's no solutions. It means it can't be factored. It means my solutions aren't rational numbers. But I can use completing the square, or I can use the quadratic formula. In this case, I would definitely use the quadratic formula because completing the square would force me to take a factor of 2 out from that 7x. And then right away having fractions, and then this, I would use the quadratic formula. And the quadratic formula again, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, I get positive 7 plus or minus the square root. Negative 7 squared minus 4 times 2 times -12. And since we had a lesson on the quadratic formula, I'm not going to spend too long on that part. Remember again, the most common place to make a mistake is right here. Like, for example, that -7 squared, if you get a little lazy typing it into a calculator, and my question is, why would you need to type -7 squared into a calculator? But you might get an answer of -49 in your calculator for that part if you don't type the brackets in. But again, we don't need a calculator to know that -7 squared is 49. So we got to be careful, but it's easy to make a mistake. We should get that discriminant, that part under the radical, should come to 145. check x equals 7 plus or minus root 145 over 4. These are the x-intercepts. That said, how do you show that on a number line? Well, you can just, again, we can just use these values here. But you might find it a bit easier if I decimalize it. So if I decimalize it, I get approximately 4.76 and negative 1.26. These are also the intercepts. They're just approximated. That's it. It's probably easier to visualize that. And so on my number line, I know I have I could put negative 1.26, or exactly 7 minus the square root of 145 over 4. And over here somewhere, this is about positive 4.76, or exactly 7 plus the square root of 145 over 4. But again, all I really care about this is the x-intercepts, and that it's opening up. So it looks something like this. And now I can focus on this right here. Where does this quadratic function, where is it greater than or equal to 0? Well, it's greater than or equal to 0 in these two intervals here, including the x-intercepts. And so on my number line, I would just show the two x-intercepts, and I'm going to put the exact values. I'm going to put 7 minus root 145 over 4, and 7 plus root 145 over 4. And again,
Ms. Caldwell, call parked on 801. Ms. Caldwell, call parked on 801.
all right, Miss Caldwell, and there we go. I want to show the interval like this on my number line. Algebraically, hoping you already kind of know what I'm going to do. Algebraically, I can say where x is less than 7 minus root 145 over 4, comma, x is greater than 7 minus root 145 over 4. And yeah, if it factors, it's faster. But there we go, we're done. And again, those decimalized versions, 4.76, negative 1.26, those are approximations. And I didn't need to do that. That just kind of helped me visualize a few things on my graph. But in the end, I didn't really need them. All right, last question, not only in this lesson, in this unit. And again, going back to some sort of basic sort of physics here. If a ball is thrown with an initial speed of 15 meters per second from a height of 2 meters above the ground, the equation that models the height of the ball after t seconds is this. So again, t is the time after you let go of the ball. H is the height. And it doesn't specify here, but height should be in meters. Okay, so write an inequality that represents the time the ball is in flight, and then find the solution to this inequality. So first, what does that mean, to write an inequality that represents the time the ball is in flight? Well, let's visualize what's kind of happening here. And let me visualize it with a graph. I have a t-axis and an h-axis. What do I know about this? Well, I know that you threw a ball from 2 meters above the ground. So the height at time 0 was 2. And you threw it. So it probably goes up and then down and then hit the ground. After that, I don't know what happened. I can't use a model to predict what happens. Does it bounce? I don't know. Does someone catch it? I don't know. But that's that sort of model there. That's it. I could continue this parabola. But it's just this interval here that represents where it was above the ground. All right. So how do I express that as an inequality? Well, I guess I've kind of done that first part. Essentially, I want to say where negative 4.9 t squared plus 15t plus 2 is greater than or equal to 0, where the height is greater than or equal to 0. However, I also have to make a little note that anything before I started throwing it, this region here, there's going to be some other x-intercept right here, but that's meaningless for my question. So as an inequality, it's where all that's greater than 0. I'm just going to move this for a second. But also where time is greater than 0 or equal to 0. Because again, if I don't include that, I have this region that I'm highlighting in yellow right here. But in terms of the context of this question, that region doesn't make sense. I mean, I guess the ball was above the ground. It was in my hand. But I don't know, like, you know, my model is no longer predicting that with any degree of accuracy. It's impossible to. So really, my interval is from this, again, this region that I have in blue that I know goes from 0 to, I don't know. So now I need to figure out that I don't know. Once I know what that x-intercept is right there, then I have my answer. My interval is from 0 to whatever that number is. So let's do that. So how do I solve for where this equals 0? Because that's really what I'm doing now. I'm now trying to solve where does negative 4.9 t squared plus 15t plus 2 equal 0. That's really what I'm trying to figure out. Or does it equal 0? Well, to figure this out, again, I can't. If I can factor it, sure ain't obvious, I would use the quadratic formula. And so, and again, the quadratic formula is, we can use it anytime we have a quadratic equation that's equaling 0, which conveniently enough, this is equaling 0. So I know t will equal, and again, using the quadratic formula, I should get minus 15 plus or minus the square root. And if you just do the calculations, you should get 264.2. Again, that is b squared minus 4ac all over negative 9.8. And so if I perform those calculations, plus minus of these, I get negative 0.13 and 3.19 approximately. And so negative 0.13, that's this solution right here, which is, in the context of this question, is not needed. So I have no interest in that part. 3.19 is what matters to me. That is what was a question mark. Now I know it's about 3.19 seconds. So now I know the ball was in flight, the ball was in the air for 3.19 seconds, from 0 to 3.19 seconds. And so therefore the solution is from 0 to 3.19 approximately. And that's when the ball was in flight. All right. And so, like I said, do not be surprised. I highly expect that any particular student would find this a bit challenging because of how it forces you to connect different aspects of this chapter together. In this case, we used the quadratic formula a few times. We visualized some quadratic functions routinely. But like I said, that forced us to make these connections. And this is a very unified unit. It's all on quadratic functions and equations. So we don't want to think of it as just a series of lessons. It's one cohesive idea. And so this is a good way to end things off. And now I'm done.